Good morning students. This session is for class 12th. Students, in last session we have completed the image formed by the concave mirror in different cases: when object is placed beyond C, when object is placed at C, when object is placed between C and F, then when object is placed between F and P. So these are the cases where we have discussed about the image formation for concave mirror, and then we have done the derivation of mirror formula when light ray reflected from a concave surface. Now in this session we are going to derive the mirror formula for the convex mirror, or you can say when light reflected from convex surface, or you can say from convex mirror. Okay, so let's start this topic, that is mirror formula for convex mirror. So in this case the ray diagram is shown in the figure, so you should pause your video and first try to draw the ray diagram which is shown in the figure. I am going to explain what is actually this ray diagram. So let's start about the ray diagram. In this ray diagram you can see the y dash is a reflecting surface and P is the pole of this reflecting surface. Now an object AB is placed on the principal axis, that is APC. You can see this APC is the principal axis for this convex mirror, right? This AB is the object which is placed here. Suppose this distance is minus u. Since the object is placed here, that is from pole to this direction, if you take the distance from pole, you must move opposite to the incident ray. So this distance must be taken as negative. Okay. So you can see one of the ray, that is Bn, travel parallel to the principal axis and reflected at point N from the reflecting surface YPY dash. The reflected ray then travel in this direction. Suppose this one is some point Z, so you can say the reflected ray travel in this direction and Z. Okay. Now at the point of reflection you need a normal, so you can draw the normal like this, which intersect this principal axis at the center of curvature of this mirror, that is YPY dash. So you can see if this one is the center of curvature and you draw any line which intersect this surface at point N, then this must be the normal at this point on this surface. So you can see here the C dash NC is normal on this convex surface. Okay. Now one of the ray, that is BP, is travel in this direction and reflected from pole P in this direction. You can say this one is P dash, so the reflected ray is PP dash. According to law of reflection, these two angles must be equal to each other, and here also these two angles must be equal to each other, right? Here you can see this one is angle of incidence and this one is angle of reflection. Similarly here you can see this one is angle of incidence and this one is angle of reflection, right? Now you can see here the reflected ray, यहाँ पे देखिए reflected ray को जब dotted line से backward direction में complete किया, so it intersect at some point on principal axis. This point must be focus, because you can see this one is the parallel ray. So after reflection, parallel ray either intersect in reality or virtually at some point. That point is known as focus. So you can see this one is the focus. Okay. Now the ray that is reflected from point P, इसको जब backward direction में लाए तो ये इस रे that is NF को point B dash पे intersect करती है, और यही पोजीशन बन जाती है वर्चुअल इमेज की। तो यहाँ पे देख सकते हैं द टू लाइट रेज, रिफ्लेक्टेड लाइट रेज, एक तो ZNF और दूसरी P', ये इस पॉइंट B' पे इंटरसेक्ट करते हैं। देन द पोजीशन ऑफ इमेज इज दिस, दैट इज A', you can say A', B' is the image of object AB, but you can see in reality no light reaches at this point. It means the image is virtual. This image cannot be formed on the screen, right? So now you can take the distance of the image from this point. This one is the V, then distance of the focus is plus F, and distance of the radius of curvature is plus R. Okay, so let us write about the things here. YPY dash is the convex mirror, AB is object, A dash B dash is image, Z, P and F center of curvature, pole and focus of mirror respectively, right? So you can note down these things, the basic information about the ray diagram. Okay, so I am going to erase these things because we are now ready to proceed for the derivation of this formula. So YPY dash is the convex mirror, AB is the object, A dash B dash image, C, P, F are center of curvature, pole and focus of the mirror respectively. Okay. Now PA is equal to minus U image, sorry, object distance. This one is actually object distance. PA dash image distance, PF focal length, radius of curvature. Okay, so you can note down these things. PA is minus U object distance, PA dash is plus V image distance, PF is plus F focal length, PC is plus R radius of curvature. You can see because the distance of P to A dash, P to F, P to C are taken in the direction of the incident ray, whereas the distance of the object is taken opposite to the incident ray. So you can see these things here, right? So you should note down these things. Now we are ready to use the geometry of this ray diagram. So let's see. In this diagram, the triangle ABP and PA', B' are similar. You can see here the triangle ABP, this triangle, and triangle PA', B', this triangle. This one is, this angle is 90, and you can see this angle is 90. So these are similar. So triangle from figure triangle A, B, P and triangle P A dash B dash are similar. Okay, so if these two triangles are similar, you can write A dash B dash upon A dash P is equal to, or you can say P dash A, P A dash, A dash B dash upon P A dash, A dash B dash upon P A dash is equal to A B upon P A, or you can write A dash B dash upon A B is equal to P A dash upon P A. Now the distances P A dash and P A are known. You can see this one is plus V, this one is minus U, and A dash B dash and AB is given here. So equation number 1 is here. Okay. So I hope you understand how this relation is written here. So you should note down this equation number 1 in your copy. Now we are ready to proceed to find out our required result. So you can see in this diagram, you should pause your video and note it down, the equation number 1. Okay. Okay. Now in this diagram we are going to use the similar triangle in figure. The triangle A dash B dash F and triangle F and M are similar. Okay, so you can see we are going to now proceed here. In figure, these two triangles, you can see A dash B dash F and F and M, or you can write here A dash B dash F, M and F, M and F are similar. Okay, so let us write for these two triangles here. I am going to write, you can write A dash B dash upon A dash F is equal to Mn upon Mn upon this Mf or Fm, and this can be written as Fa dash. You can see, let me repeat, in this triangle you can see in the triangle A dash B dash F, you can write A dash B dash upon Fa dash. Similarly in triangle F and M, you can write Mn upon Fm. Now this Nm is equal to AB, so you can replace, since Mn is equal to AB, you can write A dash B dash upon Fa dash is equal to AB upon Fm. Okay, now if M is very close to P, we are going to use the approximation. Let me repeat the approximation. If this point M is very close to P, then this Fm must be equal to Fp. So you can write Fm is equal to Fp if M is close to P, right? So our relation will become A dash B dash upon Fa dash is equal to AB upon Fp, right? So you can also rearrange A dash B dash upon AB is equal to fa dash upon fp. Okay, so let me write this equation clearly here. Okay, so we can write this equation like this: a dash b dash upon ab is equal to fa dash upon fp. Equation number 2. This equation is written here, this equation number 2. So we got from this geometry these two equations, number 1 and 2. Okay, so you should note down this part. Okay, from here you should note down till here this equation is written here. You should note down. So you can see here in equation number 1 and 2, the left hand side are equal, so the right hand side are also equal to each other. Okay, so I am going to erase these things and we will proceed. So from 1 and 2, we can write okay, you can write like this. Now fa dash is equal to pf minus pa dash. You can write like this. You can see here fa dash is pf minus pa dash, and fp is equal to plus f. You can see this is the focal length, and you can see this one is pf. Pf means focal length minus pa dash means the value v, that is image distance. Pa dash is equal to again v, and pa is equal to minus u. This one is v. Okay, now we are going to use these relations. We are going to use these values of fa, then fp, then pa dash, then pa in equation number 3. So let me use let us use so you should note down the value of pa dash is plus v upon minus u is equal to fa dash. Fa dash is pf, that is plus f, minus pa dash means minus v upon fp, that is plus f. Now you can cross multiply these two things together, so you will get v into f is equal to u into v minus u into f. Okay, now you can write down v into f plus u into f is equal to u into v. Okay, equation number 4. Divide equation 4 by u into v into f. We get, so let us divide this equation number 4 by u into v into f. So we can write equation number 4 like this: v into f upon u into v into f plus u into f upon u into v into f is equal to u into v upon u into v into f. Okay, so if you cancel the things, you will get 1 by u plus 1 by v is equal to 1 upon f. So this is the required result. Okay, so this is the formula for reflection of light by using convex surface. Okay, so I hope you understand how you can derive the formula in case of convex surface. We have already completed for concave surface. Now this one is for convex surface. Okay, so try to note it down, pause your video and note down the complete formula. Students, these are very important topics related to the reflection of light. This is the mirror formula. The maximum questions of this chapter, that is related to the reflection of light, is related to this formula. That is related, this formula is true for both concave and convex surfaces. Okay, so try to complete this formula. So students, after completion of this formula, we are now ready to study the magnification. So let's see what is magnification. So magnification. So magnification is defined as the height of image to height of object, that is, you can see a dash b dash upon ab. Now we need the value of a dash b dash upon ab. So you can use the triangle a dash b dash. So triangle ABP and a dash b dash p are similar. So if these two triangles are similar in this diagram, this one is and this, a dash b dash p and AB p. So you can write here a dash b dash upon a dash p is equal to AB upon AP. So now you can write a dash b dash upon AB is equal to a dash p upon AP. So a dash b dash upon AB is equal to, you can write here this value, that is a dash p. So a dash p, so a dash p is equal to plus v, and this one is minus u. You can write minus v by u. So this one is the magnification produced by the concave mirror. Okay, so I hope you understand the magnification. Magnification is actually this one is linear magnification. Okay, so linear magnification is defined as the ratio of height of image to height of object. You can see here a dash b dash upon ab type. So in triangle ABP and triangle a dash b dash p, you can see triangle ABP and triangle A-B-P. These two triangles are similar to each other. Then if they are similar, then we can use the property of the side of ratio of their sides must be equal to each other. So you can see this A-B- to A-P is equal to AB by AP, right? Now these two are equal to each other. So finally you can write AB upon this A-B by AB, and the value of A-P is plus V and AP is minus U. So this is equal to, so finally you can write here magnification is equal to minus V by U. So this is the magnification produced by the convex mirror. Okay, so I hope you understand what is linear magnification. Okay, so try to complete this magnification. Try to note down in your copy, because the questions related to linear magnification are very important. Okay, to complete this topic. So after completion this topic, now we are ready to write down our formula in form of magnification, and then we will complete some questions based on the mirror formula and linear magnification. Okay, so let us try to write the formula in form of the magnification M. Since we know that 1 by F is equal to 1 by V plus 1 by U, if you multiply this in V, so you can write V upon F relation in, so note first point. Now multiply both sides by V. So this becomes V by F is equal to 1 plus, so this one is V upon F is equal to 1 plus V upon U. Now since we know that M is equal to minus V by U, and you can write V upon U is equal to minus M. So you can write here minus M. So this becomes V by F is equal to 1 minus M. This implies that M is equal to 1 minus V upon F. Okay, so this one is the magnification produced by the mirror in form of image distance and the focal length of the convex mirror. Similarly, you can find out the relation for M, U and F. Okay, so I hope you can do that. So try to note it down. After that, I am going to give you the relation among M, U and F. Okay, so try to complete this one. Try to note down in your copy. Pause the video. So now in second case, you can do something like that. You can multiply both sides by U, so you will get U upon F is equal to U upon V plus, sorry, you can multiply both sides by U, so you can write like this. So this one is U by F is equal to, this can be written as 1 upon V upon U, and this one is plus 1. Now 1 by U by F, sorry, U upon F is equal to 1 upon, this is value of minus M plus 1, or you can write U upon F. You can see here, this one is U by F, is equal to u by v plus u by u. Now this is u by f is equal to 1 upon, this can be written as v by u plus 1. So u by f is equal to, this is the minus m, this is value of minus m, v upon u plus 1. Now you can write u by f is equal to, this is minus 1 by m plus 1, or you can write this like 1 upon m is equal to 1 upon u upon f, or you can write this 1 by m is equal to f minus u upon f. So m is equal to f upon f minus u. So this is the relation for magnification. This is the relation among m, f and u. So by using this relation you can find the magnification if you know f, u, okay, and by using previous formula you can find out the magnification if you know f, m and f and v. So students, these are very interesting formulas and it will help you to solve the numerical problems related to the mirror formula. Okay, the same formulas are used in both the cases, convex and concave mirrors. Okay, so thank you for joining this session. I hope you enjoyed this session and you got some more knowledge about the reflection and convex, about the reflection and mirror formula. Thank you for joining this session.